Why does the sky go red at sunset? Quick answer in 2 minutes. Because sunlight travels farther through the atmosphere, and blue light gets scattered away. What you see left is mostly red and orange light surviving the trip. Let's break it down. 5 quick points. Point 1. Longer path through the atmosphere. At sunrise and sunset the sun sits near the horizon. Light must travel through a thicker slice of air than at noon. That extra distance matters a lot. Point 2. Rayleigh scattering. Air molecules scatter sunlight in many directions. Think of light bumping into tiny particles all along the path. This scattering changes what reaches your eyes. Point 3. Wavelength matters. Blue and violet light have short wavelengths and scatter more easily. Red and orange have longer wavelengths and scatter less. So blue gets knocked out of the direct path first. As sunlight travels, blue rays scatter away from the beam. Red stays more concentrated toward the line of sight. That direct red-orange light reaches your eyes, which gives the sky its fiery colors. Point 4. What actually reaches our eyes? The short wavelengths are redirected away from the sun's direct beam, so the direct beam is dominated by longer wavelengths. That's why the sun and sky near it look reddish. Point 5. The visual result. Clouds scatter that red light across the sky, making pinks and oranges. Particles and aerosols can amplify these colors. More dust or pollution often intensifies the reds. Compare noon, overhead sun, short path, lots of blue reaching us. Blue dominates when the sun is high. At sunset, the long path filters blue out. Simple visual contrast. Technically, Rayleigh scattering strength scales with 1/wavelength to the 4th power. That steep dependence makes blue scatter much more. So even small wavelength differences matter a lot. A neat physics shortcut. Real-world particles, dust, smoke, volcanic ash, change colors. They scatter and reflect light differently, often enhancing reds. That's why some sunsets go extra dramatic. Many factors tweak the exact color palette. Recap: long path, Rayleigh scattering, wavelength differences. Those 3 explain the core idea. Blue gets tossed aside, red marches on, simple but powerful. Why pink? Scattered red light mixing with residual blues and cloud scattering. Thin clouds catch and spread those hues. Purple can appear when some violet survives, plus scattering effects. Tiny atmospheric differences change the palette. Photo tip: shoot during golden hour to capture richer reds and oranges. Lower exposure slightly to keep color saturated. A small tweak makes sunsets pop. And watch for haze or clouds, they help. In short, the atmosphere filters blue out over long paths, leaving red and orange to dominate the view. That's the core takeaway. A simple filter. The whole sky is a filter. If you like this quick explainer, follow for more quick science breakdowns. And next time you see a red sky, you'll know why. See you at the next sunset.